Hello, and welcome to a new SolidWorks lesson. In this video, we will model 3 parts and assemble them in the assembly environment using new mates. Let's start by creating the first part with a vertical center rectangle. Create a shape like this first. Now let's add the main dimensions. Set this mirrored overall distance to 150 millimeters. We do that because we want to build the other side with mirror. Now set the size of this section. Make this segment 30 millimeters and set this gap to 35. Also set this distance to 70 millimeters. Right now, this sketch is still underdefined. Select this point and the origin, then add a horizontal relation. That will fully define the sketch. Then choose Mirror Entities. Select these elements and mirror them about this center line. Now use the Line tool and connect these 2 points. Then connect the other 2 points and choose Extruded Boss/Base. Set the thickness to 10 millimeters. Next, let's add fillets to these corners. Select this edge first and set the fillet radius to 10 millimeters. Then select the other edge too. Now let's create a hinge here. Start a new sketch on this face. Now we will build the hinge. First, make sure the plane is correct. Press Ctrl if needed and continue. Here we want to sketch the hinge profile. Draw a vertical line here, then return to the first point with an arc. Create the arc like this. Then draw another line from here to this point. Set the arc radius to 5 millimeters. Set this length to 8 millimeters. Also create a hole here with a 5 millimeter diameter. Now choose Extruded Boss/Base for this sketch. Set the end condition to Up to Surface. Select this surface and click OK. Now we need the same hinge on the other side. Choose Mirror, because we want the same hinge on this side too. We need a plane that passes through the middle of the model. The right plane works well here, so select it in Mirror Face/Plane. Then choose Bodies to mirror and select this body. You can see the preview, and then click OK. The first part is now finished. Let's assign it a color too. Set this part to blue, and then save it. Create a new folder here. And save this file as part 1. Now let's move on to the next part. Create a new part, choose the top plane, and start a center rectangle. Set the width to 35 millimeters. Set the length to 90 millimeters, and then create the solid. Choose Boss Extrude here. Give it a thickness of 10 millimeters. This part also needs a hinge. Start a new sketch here and build it like the previous hinge. Follow the same method and return with an arc shape. Create the arc here now. Then add this line. The arc radius is 5 millimeters. Set the line length to 8 millimeters and add a 5 millimeter hole. Then choose Extruded Boss/Base and use up to surface again. Select this surface. That completes our second part. Now assign a color to it. For example, make this one yellow. Then save it as part 2. One more part is still left. Let's create that part 2, and then move everything into the assembly environment. Select the front plane and draw a horizontal center line as the axis. Now sketch a profile like this. Once that is done, let's add the dimensions. Set this length to 15 millimeters. Set this offset from the center line to 5 millimeters. Make this segment 5 millimeters long. Also set this distance from the center line to 7 millimeters. Now use Revolved Boss/Base. Click Yes, and create the shape. That gives us this geometry. Now let's give it a color too. Choose a light blue color and save this file as part 3. Now click New and enter the assembly environment. Here you can see the parts we created. Now let me explain an important point about the first inserted part. As we said before, the first part in an assembly is fixed and cannot move. So it is better if that first part is your base part. Let me show you that now. As you can see, this part cannot move. We also have the main assembly planes here. And this is the assembly origin. The inserted part also has its own planes. It also has its own origin. The best practice in assembly is this. Take the base part origin and align it with the main assembly origin. Give those two origins a coincident mate so they match exactly. That will help a lot later during the assembly process. First, we need to remove the fixed state. Right-click the part and choose Float. Now it can move. Then select this origin, hold Ctrl. Select the other origin too, and then choose Mate. SolidWorks will automatically apply a coincident mate here. Now the part is fixed again, and both origins are aligned. The main reference planes are aligned too, and that makes assembly easier. There is also a second way to make these origins coincident. Let me show that method too. Insert part 1 again. Select part 1 here. In this area, you can show the hidden items. Turn on View Origins here. Now the origin point is visible. You can insert the part directly onto that origin. If you click there, the part origin will match the assembly origin automatically. As you can see, the origins and planes now line up correctly. So you can use this method too, and then hide the origin again. That was the point I wanted to mention. Now let's insert the other parts as well, including part 2 and part 3. Now look here carefully. This hinge must be concentric with the other hinge, so choose Mate. Select the inner cylindrical face of this hinge and then the other one. SolidWorks gives it a concentric mate automatically. Click OK. Now this part must sit exactly in the middle of the other part. There is a mate for that. Click Mate, then go to Advanced Mates. There you will find the Width Mate, which makes this much easier. In the first row, select these two opposite faces. Then in the second row, select these other two faces. Now the part moves exactly to the center of the geometry. Click OK, and it is fixed in place. There is another way to create the same width mate. You do not even need to open the Mate command first. Hold Ctrl and select this face, then this one. And then select these two faces as well. When you click Mate, SolidWorks will suggest the width mate automatically. Click OK. Now if you look at the mates, we have one concentric mate and one width mate. Next, let's align this pin with the hinge hole as well. Open Mate again, select this cylindrical face. And then select the hole. That creates a concentric mate. Now this flat face must also be coincident with the other face. Select both faces, click Mate, and SolidWorks applies Coincident. Now you can see that this part is free to rotate 360 degrees. But we also have a mate that can limit that rotation. For example, we may want it to stop at 90 degrees and go no farther. Let's try that now. Open Mate again. There is a standard angle mate, but that fixes one exact angle. For example, set it to 90 degrees. Select the second face, confirm 90 degrees. And let me show it once more. Choose Mate, select the first face, set the angle to 90 degrees, and click OK. Then select the second face as well. Now you can see it is fixed at 90 degrees and cannot move anymore. We do not want that, so let's delete this mate. Instead, go back to Mate and open Advanced Mates. Enable the Limit Angle option and then select the two faces. I will use these two faces here. Now choose the Anti-Aligned option here. Then set an angle value. For example, set it to 90 degrees. Here you can define both the minimum angle and the maximum angle. For example, I want the maximum angle to be 90 degrees. And I want the minimum angle to be 0 degrees. Then click OK. Now you can see that this part can move only within that range. So now it rotates only between 0 and 90 degrees. You can also change this limit angle value. For example, set it to 180 degrees and click OK. Now it can rotate only between 0 and 180 degrees. So this is how you use mates to limit the motion of the geometry. That was today's exercise. In the next video, we will work with linear component pattern and copy with mates. I hope you enjoyed the lesson. Goodbye, and see you in the next tutorial.